and Sirky. Suppose a forklift raises a 688 kilogram box 2.4 meters. How much work? Well, if we're lifting, work is going to be mgh. It's going to be 688 times 9.8. I would also have no problem giving you the weight instead of the mass. Percy, the weight would be in newtons, then you wouldn't have to multiply it by 9.8 because that would be mg times 2.4. 688 times 9.8 times 2.4, and I get, you get 16,200? 16,181.76. I'll go to 3 sig figs, 16,200 joules. How much power? Power is work over time, so it's going to be 16,200. I'm going to use my answer button, divided by 45. 360, if I round off properly, 359.6, I'll go 360 watts. 1 mark. How much work will I do if I carry an 8.8 kilogram bag 9.3 meters forward? 0. 0. Because gravity is in this direction, the force that you're exerting is in that direction, but the distance is in that direction, and the force and the distance have to be in the same direction. Now, what we're really saying, Percy, is if you carry a bag flat and level, you haven't changed its energy state. You haven't given it potential energy. You've done no work. If you change its height, yes. Number 3, an electric motor develops 65 kilowatts of power as it lifts a loaded elevator. How much force does, okay, so power is work over time. Power is force times distance over time. I guess they want me to get the force by itself, so I think I'll times the T and divide the D. I guess force is going to be power times time divided by distance. Does that work? I think so. I'll have 65 kilowatts, which is 65,000 watts, time 35 seconds, divided by distance 17.5 meters. So here's yet another equation for force. Oh, you got even 130,000 newtons? Even? That was nice of me. 130,000. If you got that, 2 out of 2. Otherwise, I would probably give you, I think, half mark if I saw that equation, half mark if you got the F by itself, half mark for the numbers, and a half mark for the answer. A rifle can shoot a 4.2 gram bullet, nice try, 0.0042 kilograms at a speed of 965 meters per second. Find the kinetic energy of the bullet. Kinetic energy is going to be a half mv squared. It's going to be 0.0042 times 965 squared. You get 1,960? 1955.5725. I'll go 1960. By the way, a bulletproof vest or bulletproof clothing or bulletproof glass or whatever, all it does, because work and energy is a scalar, all it tries to do is spread the energy out over a much larger area. So if you get hit while wearing a bulletproof vest by a bullet, you're still having to absorb the energy, but instead of in a small enough area that it can penetrate, we're going to try and spread it out. We're hopefully going to break a rib rather than penetrate. We'll try and spread it out over your whole torso. Much better alternative. What work is done on the bullet if it starts from rest? Well, work equals force times I don't see a force or a distance. Work is also the area underneath a force versus distance graph. Don't see a graph. So it's also going to be the change in potential plus the change in kinetic. I don't see a change in the height here at all, so I think it's going to be kinetic energy final minus kinetic energy initial, although it says starts from rest, so I can do that. You know what? I've already got the answer. That was easy. The work is going to be 1,960 joules, because that's how much kinetic energy the bullet got, starting with no kinetic energy. I probably could have reasoned my way to that sky without writing anything down, but I wanted to walk you through that's how my brain would have handled this. If the work is done over a distance of 0.75 meters, so the rifle barrel is about 3/4 of a meter long, what's the average force of the bullet? Harsh, again, I said average force because I suspect in real life the force isn't constant, but whatever. Well, work equals force times distance, so force equals work divided by distance. It's going to be 1960 divided by 0.75. Page, I wrote 1960, but I'm going to use my answer button. You get 2,600 newtons? 2,610? Next page. Potential energy. Well, that's going to be mgh 50 times 9.8 times 400. That's what 4 times 10 to the 2 is. Can I do that one in my head? Well, yeah, sure I can. 400 times 50 is going to be 20, and then 3 zeros, so it's going to be 20,000 times 9.8. 490,000? Let me double check. No, 100. Wow, totally off. 196,000. What did I do? Dude. Oh. 9.8 times 2 is 19.6. I multiplied by 5 twice in my head for some dumb reason. Joules of energy. What's the change in potential energy when it falls to, okay, change in anything is going to be fine. You know what, Mr. Dewick? It's going to be mgh final minus mgh initial. Mgh final is going to be 50 times 9.8 times 200 minus mgh initial was 196,000. The other thing I noticed is what we're really saying is what's the change in potential energy when it loses half its height? I think I could just divide 196,000 by 2. That would also get me there. 98,000, but it is negative. What's the negative mean? It lost potential energy. I will be fussy if you didn't put the negative here, because change in anything is final minus initial. I would take a half mark off if you left the negative off here. It lost energy. Where'd the energy go? Bumping into air molecules and giving the air molecules kinetic energy, moving them out of the way. A little bit into heating up the air molecules. Kinetic energy of the bike and rider. Kinetic energy is a half mv squared, 0.5. 85, 8.5 squared. You get 3,070. Coasts up the hill. Assuming there is no friction, at what height will the bike come to a stop? So is there a change in height? Is there a change in speed? This is a job for conservation of energy, but I'm going to, Kyle, be a bit bold. I think I'm going to argue that all of your initial kinetic energy turns into all of your final potential energy, because it says comes to a stop. So I didn't write out Emma the full KE initial plus PE initial equals KE final plus PE final. I said I'm pretty sure it's my kinetic turns into potential. I think it's going to be 3,070 equals mgh. I think h is going to be 3,070 divided by mg. It's going to be this number divided by bracket 85 times 9.8. You get 3.68 meters? People nodding? What happens to the kinetic energy if we double its velocity? 4 times larger. What if we tripled its velocity? 9 times larger. That's why, by the way, so for example, I don't know if any of you have seen or looked at electric bikes. When they advertise the range of an electric bike, there's so many variables because it depends on how fast you're going. Because if you decide to use the electric bike at its top speed, that squared's going to kick in. You're going to be bleeding energy from that battery way faster. Or even gas mileage for cars. It all depends on how you drive. Oh, and the M doesn't cancel, so a heavier person will use up the energy faster than a lighter person. Suppose a toy car at the top of a ramp, 3.3 meters tall. Okay, how much kinetic energy will it have when it reaches the bottom? So I think all of my potential energy is going to turn into kinetic energy. I think the kinetic energy final is going to be mgh initial. It's going to be m 3.5 G 9.8 times 2.3. Do you get 78.9? People nodding? Yep. Joules. You know what, Mr. Dewick, why don't you be clever? And there, now it all fits on the page. B. What will its speed be at the bottom? Well, I guess 78.9 is going to be mv squared over 2. It's going to turn into kinetic at the bottom. So 2 times by 2 divided by m square root. V is going to be 2 times 78.9 divided by 3.5 square root. 2 times answer button divided by 3.5 square root 6.71. So for 3 marks, I would probably give you, I think, how would I have marked this? Honestly, probably 0.5 for that. 0.5 for the numbers. I would make A 1.5 marks, and then 0.5 for that, 0.5 if I saw that equation, and 0.5 for the answer, but 3 marks if you got it right. Can you give yourself a lovely score? This quiz was out of 16. Any lawyering with me? Now is the time.